Let's wait till I think 7:10 or 7:05, और मतलब बाकी जगहों पे नोटिफिकेशन डाल दो, उसके बाद शुरू करते हैं.
भैया अकाउंट एजुकेशनल मेल से बनाना था या
हाँ,
अपना पर्सनल
एजुकेशनल
मेल?
से बनाओ, इट विल बी बेटर. We'll explain about Tinkercad during the session.
भैया आर्डुइनो का टेस्ट एडिटर अभी डाउनलोड करना जरूरी है?
मतलब आईडी कर लो डाउनलोड, इट विल बेनिफिशियल फॉर यू, बट इस सेशन में
वो
ID
विंडो 8 पे हो रहा है, मतलब विंडो 8 पे हो नहीं रहा, 10 पे होगा.
अभी के लिए तुम स्किप कर सकते हो, कोई ऐसी
कर लो, बट मतलब बेटर रहेगा कि डाउनलोड करके रख लो बाद में.
अभी सेशन के लिए नहीं रिक्वायर्ड, वैसे अगर करना है तो
तो गाइस सेशन शुरू करें, मतलब 7:05 हो गए हैं, बाकी लोग ज्वाइन कर लेंगे.
या लेट्स स्टार्ट.
रुक जाते हैं 5 मिनट और, रुक जाओ.
या 5 मिनट और रुक जाते हैं, देख लेते हैं अगर कोई और ज्वाइन करता है.
ठीक है.
यहाँ ऐसा करो, इंट्रोडक्शन से स्टार्ट कर दो. अब मेरे ख्याल तब तक टाइम भी हो जाएगा. ऐसे
इंट्रोडक्शन कर
लेट हो
देते हैं,
जाएंगे
टेक्निकल पार्ट तब तक वो पहुंच जाएंगे.
हाँ ठीक है.
ओके.
तो मैं टैब शेयर करता हूँ. So you all can see the slides, right?
यस
यस.
यस भैया.
Okay, so let's then start the session. Hello guys, I am Pritish, coordinator of Robotronics Club IIT Mandi. So here we are having our first session on Arduino. So hope you are all excited to have this session. So okay, I'll just first introduce you to our core members who are conducting this session. So naming Priyanshu Singh, Priyanshu Singh, Priyam, Prashant, Deepak, Abhishek, Tanmay, Dipanshu sir, and Arjun sir. So now let's talk about Arduino. Arduino is like the basis of robotics. Like it's quite simple, but it helps to make quite let's how do I say, to make like I guess you have listened about line followers and the robo races and robo wars, if I'm not wrong. So these all are just made from Arduino. It's like the basic. So let's just talk about what is Arduino. First, I'll ask you guys if you know what is microprocessor or a microcontroller. Like it's not a prerequisite that you must know, but if you guys, if anyone knows, if she wants to tell. Okay, so let me tell you about it. What is microprocessor? Microprocessor is basically like your CPU, but the simple difference is that it is on an integrated circuit. Like CPU, it takes input, it processes the data according to the instruction it has, and then it gives an output. It does not has its own memory. But coming to the microcontroller part, it's like a small computer. it has its CPU, it has its memory. So basically, what a microcontroller has one or more microprocessors in it. What happens? We give the input, it has the memory in which the code is or anything is stored. Then we give the information to the microprocessor, and then output is given. So, okay, now let me tell you what is Arduino. Let's talk about Arduino, right? So basically, Arduino is an open source electronic platform based on the ease to use hardware and software. Okay, so basically, what is Arduino? It's basically an open platform to just make the projects and all. Arduino basically board consists of microcontroller. So like it has a memory, you just save your code in it. So you give the power to it. You have some pins on it. I'll just show you the structure of Arduino, how it looks. So basically, what you do, it has a power socket to just give it the power. You have some pins to input the code and to run the motors and all. And it has a memory in which you store the code. Okay, so and Arduino are also of Arduino boards are also of two or three types like Arduino Uno and Arduino Mega. The difference in these comes in the memory and the microcontroller they have. Like the Arduino Mega has more pins than Uno, and the microcontroller in the Arduino Mega is 2560P. So basically, all it is Arduino software, easy to use for beginners, but flexible enough for advanced users. You can make your own bots from with Arduino, like home automation and all stuff. All these are basic stuff, but are done from Arduino. So now let's move on to how Arduino looks like and what are its components.
So hello guys. So coming on to the technical stuff. So I hope most of you have joined the session. If not, then let's start the technical stuff. Okay. So I think Pritish has explained to you what is Arduino, right? It is basically a piece of electronic that is used to solve some real world problems, right? We use it to run motors, run modules, match temperature, and many more. So right now, what is this? So this looks like very much similar to a motherboard, right? I think most of you have seen motherboard in your textbooks or somewhere. So like this is a silicon chip on which there are modules fitted and they are connected through different pipelines to each other, right? These pipelines, as you can see on this silicon chip, are basically the flow of data that you can see. But you don't have to go in the technical stuff. That is the beauty of Arduino. Like all the technical stuff is done behind the scenes, and you get this beautiful motherboard in front of you, which consists of the pins, module. This is a microcontroller, this big black thing, and which has a USB port. It is a two power sources. You can power it using a USB port or a adapter, and there are reset buttons. So I'll be briefly explaining these modules. It might be a little bit boring, but bear with me. The interesting stuff will come, but it will come a bit later. So right now I'll be explaining to you the modules. So these 13 pins that you can see, which are labeled from 0 to 13, are called the digital pins. Now there is a reason they are called digital pins. They are called digital pins because either they take input in form of digital, which is 0, 1, true, false, yes, no, or in this case of Arduino, 0 volt or 5 volt, or they provide output to different modules. Like you can connect an LED to these pins, right? And it will provide either 0 volt or 5 volt to that LED. So 0, 5, two constant values define digital. So that is the main function of these pins. These pins are the receiving ends and the giving ends of your main Arduino board. Consider it as a machine, and using these pins, this machine interacts with other modules. Okay. So most of the pins are numbered normally, right? 1, 2, 3, 4, 5. But some pins have this tilde sign. So what does this tilde sign signify? Now, this tilde sign is a little bit special, as the pins that are labeled with this tilde sign can take analog values. Like they are not constrained to only 0, 1, 0 to or to 5 volt. They can also take values between 0 to 5 volts. So that makes them ideal for reading temperature values or giving variable voltages in order to upscale or downscale the brightness of LED that you have connected, or any other module or functionality of the module. Now we can see that there are pins numbered from 1 to 13. Now there's a pin named ground. So what does ground mean? Ground means 0 volt. 0 ground generally means zero potential, right? We say that earth has zero potential, all the higher potential bodies go into the earth, right? So since we have pins from 1 to 13 that can provide us voltage called constant 5 volt voltage, we need a pin called ground that can provide us a constant 0 volt voltage, so that we have a flow of current, and like so we have a potential difference. And so if we connect an LED, it can like it can burn, it can light up, right? We need a 0 volt uh, pin if we have a variable volt pin, right? So that is the function of mainly ground. It is basically a 0 volt source. You can consider that. Now coming on to these pins are named from A0 to A5. The A consists means analog. The function is very much similar to the tilde ones. They basically take in analog values like these. The pins that are without tilde, like this small sign, take only values 0 or 5, like only two values, right? But these, either the pins with tilde sign or the pins with a named A0 to A5, can take variable values between 0 and 1. So these are ideal if you are having a temperature sensor, because it returns values in a wave form. So these pins can read the information. Also, coming before explaining, wait a second, I should have used a pointer, sorry. So before explaining these pins, I'll be telling you about the USB port and the this DC connector. So the USB port is very special port, like it is the only port which connects to your computer, which connects the Arduino to your computer. It acts in two ways. First of all, it acts as a power source to the Arduino. You can power your Arduino through your computer by connecting it through the USB port, and the power is constant and non. It is really a constant amount of power, which really like does any harm to your Arduino, as the ports are conditioned to provide constant voltage, or your computer ports or your laptop ports. So also you connect your Arduino to your laptop through this USB port, and then you can upload the code from the Arduino IDE, which would be installed in your computer, to your Arduino board. So that is the main functionality of this uh, USB port. And this, what do you call this? This is called DC connector, right? So the function of DC connector, it is basically a connector for your DC adapter. That DC adapter basically fits directly into your home switches or anything, and that adapter converts the AC signal that is flowing in your home to a DC 20-volt DC power that then flows into your Arduino. And then actually the Arduino also has some regulators for itself, so that it does not receive more than 5 volts, because more than 5 volts normally causes harm to the functionality of the Arduino. Now coming on to these pins, right? So what is V in, ground, 5 volt, 3.3 volt mean, right? So V in is basically if you want to give voltage to the Arduino. So it mainly takes voltage through this V in pin, and you are advised not to give more than 5 volts to the Arduino. And the ground pins have similar functionality as the above one. They are basically 0 volt sources that will help you when you connect to modules. And the 5 volt, now this is a very special pin, because this is the pin that provides voltage outside of Arduino. Like you want to power another Arduino from this Arduino, or any other module from this Arduino. Then you can use this 5 volt pin to provide a constant 5 volt voltage to that module. And a 3.3 volt pin is provided specially because there are some modules that require that much voltage. Like some modules don't run at 5 volt, they simply burn out at that voltage. So there's a separate pin available with 3.3 volt constant. So that is the main components that you'll be using in this session, if I'm not wrong. Another important part are the TX and RX LEDs. Now these two LEDs are really important in your Arduino, because these two LEDs basically indicate that whether your Arduino is functioning properly or not. Basically, these two LEDs indicate the flow of data, that either if the Arduino is transferring data to your computer, or if your computer is transferring some data to your Arduino. So like if these LEDs stops blinking, there is some problem in your Arduino. So always keep an eye on these LEDs. Okay. So that was just a brief explanation of the Arduino board. I'll be showing you a video that will cover all these modules in much more detail. So coming on to the next slide. Yeah. So blinking an LED. Guys, this is the task for today. You'll be making an LED blink through your Arduino. It is quite a simple task. You might say, why are we using Arduino, such a powerful machine, to make an LED blink? But that is the basics, right? We all start from somewhere, and this is a really how should I put it? An easy task in order to understand the various functionalities of the Arduino. Okay, so I think you all know what an LED is, right? What a photoelectric diode, right? LED is just a photoelectric diode. I think you all know it. Yes, ma'am.
Yes.
Yes.
Okay, so yeah, you can see the next slide, right? The diode one. Yeah, right. So the LED is basically a photoelectric diode, right? You connect one end to the voltage source, one to the ground, and there is a resistance in between. Now the Arduino itself has an internal resistance. So when you connect an LED, there is you can connect an resistance of 220 ohm, but it's your choice, right? You can either use it or not use it. That depends upon you. I'll show you the circuit of the LED module with the Arduino. This. Now this is the circuit of an LED module with Arduino. Now it is made a little bit complex, but no need. I'll explain to you. So what is this white thing right here? Do you know what is this white thing with so much holes in it?
PCB.
Breadboard.
PCB.
So can
Breadboard.
someone explain the use of breadboard?
No.
So is everyone known that what is a breadboard and what is how it
Okay,
works?
I'll just
Okay,
briefly,
No, we don't
No,
know.
no, we
okay,
don't know here.
I'll just briefly explain to you the use of breadboard, right? So you can see the breadboard has a lot of holes in it, right? It is divided into how many columns? One, two, three, four. So it has been divided into four columns, right? Now the columns, the middle two columns have the same property, and the end two columns have the same property. Now what is that property, right? So the property that the middle two columns has is that the holes that you can see vertically, like one vertical line, you can see how many holes? One, two, three, four, five. You can see five holes, right, in a single column. So in the middle two columns, the five vertical holes are shorted. That means they have the same voltage. So if I connect a 5-volt source here, then all the vertical pins which are adjacent to it will have 5 volt. And if I connect here 0 potential volt, you can see the ground pin is connected to which one? This one, right? So all the above pins have 0 volt because I have connected it to ground. So hence I don't need to connect the LED directly into these pins because the slots are limited. Now I have 5 more slots with 0 voltage. So I can just connect one LED, one of the ends of LED to any of the pins, and that would be providing a 0 volt potential to the LED. Any doubts here?
Please re-explain.
Okay.
what do you
So
mean to explain?
what I'm saying is that the vertical pins that you can see, the vertical holes that you can see in the LED will have the same potential as, oh, wait a second, I'm receiving a call. Okay. What I'm saying is that all the vertical holes will have the same voltage. Okay. So if I connect a 0 volt source to any of the column, any of the holes, then all the above holes will have the same 0 volt potential. Okay. So like can you see the ground button here, ground pin here, right?
Hmm.
Sir, sir, only above holes will get same voltage.
Yeah, only the vertical one. Like there are 5 vertical ones, right? One, two, three, four, five, right?
So the lower
No,
half
no,
will not get.
lower half will not.
No, hello.
No.
Can you
I mean to
listen?
say that all the vertical, like if you connected it here, then all the lower will have it. Yeah, that was nice question. No.
Okay,
So
please
like
explain this
all,
question again.
like what I'm saying
So
is that, hmm, yeah, bolo.
whole vertical column of the breadboard get same voltage.
Yeah. Oh, no, there are 4 columns, right? The middle two
Uh,
columns have a special property that,
hello, Abhishek.
bolo.
Yeah, maybe I can
Buteka,
try to explain that. So, can you here see that there is one red line, then blue, and again a red, and then a blue line? Yeah, you can see that.
Yes.
Yeah. So
Yes.
the topmost one. Let's go down vertically. The topmost one between the blue and the red line, it represents a section. Then there is a section below the from the red line to the middle line that you can see that is going through uh, like a kind of a fat gray line that is going. So it is section number 2. Again, from that gray line up to the blue line, it is section number 3, and the
Sir,
last one between the blue and the red line, you can say it's section number 4. Yeah. So now the
what?
section number 1 and section number 2 are having all the pins shorted horizontally. So you understand the meaning of shorted? Okay.
Yes, sir.
So shorted means that among these pins there is a you can say a kind of wire connecting all of these pins. So you can see there are 2 rows in section number 1, right? So each of these rows are connected independently. So say row number 1, in row number 1, if we provide a 5-volt potential anywhere else, so all the pins that are available in row 1, they will be at potential of 5 volts. Similarly, if we provide a potential of 2 volts in the second row, then all the pins in the second row will be of potential 2 volts, right? So let's move on to section number 2. So section number 2 and section number 3 are similar, like just like section number 1 and section number 4 are similar. So now see the section number 2. In section number 2, we are having 1, 2, 3, 4, 5. There are 5 rows. Okay. So you can understand my row and column terminology, right? If anyone is having a confusion, what is a row, you can ask. Okay. Cool. So in a row, let's consider row number 1. Okay. So row number 1, as you can see, there is a small numbering going along by. So it is maybe denoting 40 number of columns. So among each of the column, what is there is that all the pins are shorted. So now the pins that are shorted are vertical, or you can say that along a column. So as you can, let's see the diagram now. So the black wire is at the ground from the Arduino, right? And it is going to say some column number X in the second section. So in that same section above, in the same column, we have a node point of the LED. So it will be acting as the negative of the LED. The cathode of the LED is in the next column, so that we can have a potential difference among them. And then we just like to have a resistor in series, we have put down and maybe it is a 2.2 kilo ohms resistor in the same column as that of the LED. So the second pin is again in section number 3. So it is at the same voltage now, and then it runs back to section number 4. So in section number 4, as the pins are shorted down horizontally, so we are providing with a pin number 13 from the Arduino that is running into it. So any potential that will be here will be provided same to the lower end of the resistor. So there will be a potential gap between the ends of the resistor. So say it will be about 2 volts. So if we provided 5 volt here, the lower end of the resistor will be at 5 volt, the above end will be at 3 volt. So the cathode end of the LED will be at 3 volt, and the anode end will be at 0 volt. So that is how your circuit is working.
So like I hope you got it, but if you don't, there is no need to worry. You'll get these things eventually, and we'll be explaining to you in the Tinkercad part if you are having further doubts. Okay.
So,
So
sir,
now,
sir,
bolo, bolo.
instead of joining it in the G row, if we join it at the same point in F row, will there be no effect of it?
You mean to say that if I
Yeah,
directly
just
join these
below
two
point.
down,
The black line just
no,
below
no,
point.
here.
Yeah,
Yeah, no problem. Since
it will
the
work same.
same. Since the vertical pins are having the same voltage, so if you connect the black line below, well, 1 point below here, then it will work the same, no problem. Okay,
Okay.
so going to the next slide. So the programming aspect of Arduino, okay. So like Arduino is actually quite basic in terms of programming aspect, because you can't really use complex modules like image processing and other things. So Arduino uses very basic logic things like if else, for loops, while loops, what do you say, true, false, 1 0, like simple logical stuff, right? And the main coding language that Arduino uses is either C or C++. But you don't need to be extremely deep in these languages. Just simple if else stuff will do your job. Okay, and like this session is mainly logical based, so we are not going to use very complex terms anyhow. And there are some built-in functions that would be used to simply like name the pin, right? Because C++ does not provide any function inbuilt, so there are some inbuilt functions in Arduino that are used to name the pin and like make it as variables. So we'll be explaining it further in the Tinkercad department. And yeah, the so why do we need code, right? We need to code because to we need to perform some logical operations using this machine, right? We need to run a line follow. That is a logical operation. We need to check whether the bot is on a line or not. That is, if it is a bot is on a line, then move forward. If it is not on a line, then don't move. Simple logic. So we need to code. Okay. So coming on to how to download the software. So Deepak.
Okay. आवाज आ रही है? Hello. Hello. Am I audible?
Yes.
Yes, sir.
So now we have shared the link to download the Arduino IDE. If you haven't, there is no problem. You can download it after the session. We will be providing you the link. The website given, you can download it from here. We will be providing the link. So after downloading the Arduino IDE from here, you will be getting a folder like this. So here we have to only go to the Arduino IDE. There is an extension arduino.exe. After opening it, you will be getting after you opening you will be here. So now what you have to do, so here we write the code. Arduino is just only a machine. To tell what to do and how to do, we have to tell that how to do the code. So here we write the code. We can connect any Arduino board. We can connect Arduino Uno, Mega, Nano, etc, etc. The same software will be used for the all Arduino boards. Then here we are having a void setup. So what we write in void setup? In void setup, we write the value, means variable, which is used single times. It means that see, if we want to blink an LED, so for all LED we will be having different variable for all different LED. Say for example, LED 1 will having some point input at 12, then LED 2. So we have to use different variable, means different value for all the different things we need. Then we are having void loop. So what we write in loop is the thing that we want to continue till the process will be running. So it is like loop, means one by one it will be continuing and will come to the start point, means from starting to end. Then again it will come to start, then end, then start, then end. It will be continuing till that we stop it. So for this session we don't need Arduino IDE. The Tinkercad is having its own Arduino IDE in the website, so we'll be using that. This Arduino IDE is used when we are having an Arduino hardware with us. So this is the thing basic to know. So now Tanmay will
Guys,
be continuing.
for right now, for the sake of simplicity, only just remember that setup is used run only one time when you run the program, and the loop run over and over. So most of the code was written in a loop where we actually write our logic, which run over and over again.
Hello. Am I audible?
So guys, now comes
आ
the
रही आ रही आ
important
रही
part. So अब इसको संग से सुनो, यहाँ पर अब काफी इंटरेस्टिंग चीजें होगी.
Yeah, so guys, now for the blinking LED part, now what do we need Arduino to do with the LED? So we need the Arduino to give the power to the LED, say 5 volts or something. Like we need the LED to be on for some specific amount of time, and for the sake of symmetry, say the LED stays off for the same amount of time. So this is the basic pipeline of the, by pipeline I mean the workflow of the blinking LED. Uh, so next slide. Yeah, so this is the basic code which we'll be using. If you don't understand it now, don't worry. I'm gonna take it up in the Tinkercad part 2. I'm gonna explain it detailedly. So this is how the basic code of the Arduino IDE looks. So next slide. Yeah, so now we'll just head on to the Tinkercad website. I hope you all created your own accounts.
So you guys can actually open Tinkercad side by side in order to like do it right now with us.
Okay. So I think I'm presenting right now, right?
Yeah,
Is
you
my
can see.
yeah, nice. So this is the basic. This is the Tinkercad website. So you need to register your account from this join in button here on the right side. And if you already have created your account, just sign in by this button. So I have already signed in. So this, when you sign in, you'd be taken to this interface. Like you would be taken to the 3D designs and 3D design interface. So make sure to go to the circuits. So this is where we would play with the Arduino. And from here, so if I'm going a little fast, please do speak up. So I might slow down. So from here, go to create new circuit. So this would open up the Arduino, the simulator for Arduino. It takes some time. Yeah. So this is where you would be taken. Now from here, go to the search bar on your right side. Search for Arduino. Yeah. So Arduino Uno R3 is the board we would be working with, and this is also the board which we have like in a more number in our campus for doing it hands-on. So for taking it to the working part, just click on it once with left click, and you would get the Arduino board on your mouse. So keep keep pressing the button, take it to the place where you want to keep the Arduino, and just leave it there. So you can also name your board here. And now just remove this Arduino text here, and from here and by the same process you can take the LED here too. Yeah, so for now I'm just constructing the circuit of this blinking LED. I'm going to explain why I'm doing this, why I'm connecting the particular pins to say pin 13 or ground particularly through the code. So don't get confused to why I'm connecting it to the specific pins right now. And excuse me?
There is a doubt in the chat. Someone asked you to just repeat the new circuit part.
Again, repeat
Yeah.
from
Okay, yeah,
creating.
I'll do it. So I think you guys are here to this part, right? Speak up, guys. Unmute कर दो अपने आप को क्योंकि I'm not looking at the presentation. Sorry, I'm not looking at the meet. Hello.
Yeah, I guess you can wait a little if someone responds to it.
Okay. Once you guys get to this window, please respond.
Yeah, Rajat, actually, we are not getting any noise. Maybe you can try rejoining the meet. Yeah, so they are there. They have reached us today.
Okay, so on this search button on your right side, type Arduino. To press enter. So okay, let's say you would be shown Arduino Uno R3. Yeah. So left click on it. Don't just remove your click. The Arduino board would float over your mouse pointer, take it to the place where you want to put it, and leave the button. So there's your Arduino board. And by the same process, like no need to search for LED, you would be taken to it directly. The LED would be visible right here. So by the same process, like click on it, it would be shown on your mouse pointer, take it to the place where you want to keep it, and leave the left click. So you need to use left click rather than the right click here. Same process resistor to it, like you guys can work without the resistor too. So the resistor is basically to regulate the voltage to the voltage that is being given by the Arduino board to the LED, so that we might not burn the LED up. You know, right? The LED will have some maximum voltage, and above that voltage the LED would get burned, the diode in it would get burned due to short circuit in it. So I think there is no doubt till here. Hello guys.
Yeah, continue.
Yeah, so now for connecting part. So you can just only by hovering your pointer on the LED, you can see that it's highlighting anode and cathode part. So click on the anode part once. There would be a green. The color might vary, but a line would be coming out from that point. So take that point and just click on the pin 13 here. So pin 13 is important. Don't connect it to other pin 2, because we'll be providing you with a code which has defined that pin 13. Like I would tell you why I'm taking that particular pin soon when I would be explaining the code. So and by the same means, connect the LED to a resistor and the resistor to the ground pin. You can see the ground pin here, right? Yeah. So I'll just zoom it. Yeah. I'm just for zooming you can use your wheel button of your mouse. So I'm connecting the cathode of the LED through resistor to the ground port of the Arduino, and I'm connecting the anode of the LED to pin 13. Yeah, so you can sorry. So this is the basic connection. You guys can change the colors of the wires too by clicking on it once, and you can see that you can change the color here. So I would just be taking this cathode part to black so as to just distinguish it from like positive, so as to distinguish the positive and negative parts of the circuit. Now coming to the code aspect of Arduino. So if you want to code the if you want to give the logic through which the Arduino should work on your particular circuit, so you need to give the code here. So for the code, just click on this code button. You would be taken to this part, and be sure to from this drop down menu, be sure to click it on text. Don't go on blogs or blogs plus text, because text is where you would be shown the code part. Yeah, so continue. Yeah, so there is already a basic code that's been given here already. So as said before, the part in this void loop would be run
Excuse me,
only.
sir.
Yeah.
So what to do after code?
So you would be like, I think there would be this basic. I would just paste it on the chat. You can, I think, if it doesn't appear on your webs on your interface, you can just copy paste it. Yeah, I just given it in the chat. Just copy paste it for now. We are not going into the code aspect since you guys are not too familiar with the code right now, right? I think there is no programming course for you this semester. So so as you guys were told earlier, the code inside this parenthesis of while loop would be run only once for the whole simulation by the Arduino. So I would get through what it is soon, and the part inside the void loop would be run always. Like after this statement has been executed, the Arduino would run the step one again. Like think of this as step 1, 2, 3, and 4. After the execution of step 4, again the Arduino goes to execution of step 1. Now coming to the setup part. See, the pin mode is a function which tells Arduino to give the particular pin. Say I'm saying here pin 13. Say for example pin 13. I'm telling Arduino here to give the pin 13 to make the pin 13 an output mode. That is, I'm telling the Arduino to give output at the pin 13 rather than taking input. Taking input means I'm supplying voltage, like supplying voltage at that particular pin. So we would get to that input part afterwards, I think mostly in next session. So through this pin mode, this is the basic thing that we would convey. Like we are saying that we are telling the Arduino to uh, to take the pin 13 into the output mode. Now coming to the void loop part. So digital write says that for at pin 13 at t equal to 0, say at the execution time at t equal to 0, we need the voltage at pin 13 to be high. High means in this case 5 volts or 5 volts, and the delay, the thousand here is in terms of milliseconds. So after giving the pin 13 5 volts, I'm asking the Arduino to wait. Delay means I'm asking the Arduino to wait for 1000 milliseconds. By 1000 milliseconds, I mean 1 second, right? You know, the 1000 milliseconds is 1 second, right? So I'm asking the Arduino to wait for 1 second. So after 1 second, I'm gonna tell the Arduino again by this digital write function to pass the voltage at pin 13 to low. By low, I mean 0 volts. 0 volts in the sense like equal to equal to the voltage at the ground pin. After that, I'm gonna tell Arduino to wait for another 1000 milliseconds. For 1000 milliseconds, I mean 1 second. So after 1 second, since there is no part here that since I'm telling it nothing to do here, and this code is in the void loop, so the Arduino board, the microcontroller jumps back again to the first step, and it turns the LED on, and it turns it sends the high voltage at pin 13 once again. This would keep continuing on forever till we stop the simulation. So for running the simulation, if our code and our connections are right, we should get a blinking LED now. So for starting the simulation, just click on this start simulation button. Also take some time. Yeah. So I think, yeah. So you guys can see that the LED is getting on for once. It stays on for 1 second, and it stops for 1 second, and it stays on. For you can be sure of the time limit by changing the delay, by changing the amount in the delay, sorry, the number in the delay, and you can confirm it by yourself. But remember, this would be in terms of milliseconds rather than seconds. And once you, like, if this doesn't work, if you want to change your code, if I try to type anything here, it won't work. See, I'm typing something on my keyboard, like some A key or D key. So it doesn't work because the simulation is running right now. So if you want to change your code or change the wirings and everything, you need to be sure that your like the circuit is not on simulation right now. So you need to stop the simulation, and now I can make changes to the code. So this would be frustrating sometimes, so it is good to know. I think this would be it for now. And one more thing, I think, yeah, so I think you weren't told about serial monitor in Arduino. Serial monitor is mainly used to, like, this, yeah, on this serial monitor, the Arduino board sends the commands. Like we can say, like we can tell it to print a particular statement when a particular line is being executed. I will show that right now soon. So we can also use this serial monitor. We can also use the serial monitor for debugging too. Like we shall let's just try using the serial monitor once now. So for using the serial monitor, just type serial dot again 9600. Don't forget the colon mark, and remember I'm typing this command in the void setup loop. Yeah, so after that I'm gonna go to the void loop area. I'm gonna print serial dot print. That's print ln. Look, you guys can wait. I would just copy paste it on the chat too. Okay, we shall change it to 2 seconds so that you guys can see it properly for now. And I'm just gonna copy this step, paste it here. So no doubt still no, right? Please do respond if you have any doubts. Take this.
Excuse me.
Yeah,
Can you just again explain the serial begin part?
serial begin part. Yeah, okay. Like the serial begin statement here inside the void setup tells that we are gonna stay. See, I'm not going to the technical aspects right now so as to not confuse you more. So I'm this state by this statement, I'm just conveying the Arduino board to I'm just conveying the Arduino board that I would be using the serial monitor during this particular projects during while I would be using this particular circuit. So by this statement, I would mean that am conveying the Arduino board that I would be using the serial monitor, like I would be using the serial monitor to see the output. Say I would be seeing the serial monitor for printing of a particular statement, or I would be using it to give any input. Yeah, you can give input through the serial commands too, but let's just leave that part for now. And by this serial print, this is serial print ln, so serial print line. So by this we are saying the Arduino board to print this particular statement. When this statement has been executed, this statement would be printed on the serial monitor here, and the same case goes to this too. See, the semicolon here means this particular command has been entered on this line, and you need to move on to the command on the next line. So when the Arduino board has given high voltage to that to the pin 13 at say t equal to 0, it would move to next statement, and it would print LED is on the serial monitor. After that, it would wait for 2000 milliseconds, and after that the LED would go off. See, it would be clear if when I run the simulation. The LED is on. You can see the serial monitor, the lines are being printed on the serial monitor, which the statements which I gave here inside the code. When the LED is off, you can see the statement is being printed on. And now the time gap between those between both of them is 2 seconds, like since I gave them 2000 milliseconds here. Remember, this is important. The units here for this number is milliseconds, not seconds.
Sir, what is the use of 9600 there?
Yeah, so I think I don't remember the why that particular number is used. Dipanshu sir, do you remember why that's used?
Yeah, so you're asking about that 9600, right?
Yeah,
Yes.
Okay, can you show that tab?
yeah. The code is this.
So see, 9600 is actually a baud rate, BAUDRATE. So baud rate is nothing. It is like the clock cycle. So it is consider a wave. So wave is having a frequency, right? So if a wave is having a frequency of 9600, so hertz, I'm talking in hertz. So it would be like in 1 second, 9600 times a wave will be having its entire cycle. So it's now understand it in the way of Arduino. So Arduino works on the basis of clocks. So there is a bit time there, that is a specific time that addition or subtraction is carried out within the Arduino. So it is that in a single bit time, it will be 9600 times that the serial will be pinged by the Arduino board. Yeah, does it make any sense?
No. Please, can it a lot more elaborated?
Yeah, see, say it is 9600. Say you could change it to some other thing. So it will be basically like So it will be basically like if you increase the number, there will be a more of the capacity of the Arduino that will be required to ping the serial. So see, a serial monitor is something on the PC. It is showing you the output. So for serial monitor to work, the Arduino tells, yeah, this is the state of my Arduino board right now. Please show it. Please show it if you need anything else, anything from this part. So serial monitor will, depending on the state, show the output that we require. So if you keep the baud rate to be too high, then it will be, then you may see some kind of errors too. Actually the baud rate, it is in a standard way, it is generally kept about 9600. So you can skip that for now. But like in a more sophisticated way, you can say that like changing these values may have some effect on the actual practical scenario when you will be working on
So
it.
like right now, these will not have any changes because you are simply like displaying the on and off, right? But when you connect modules to it, say you connected a temperature module, right? Now you don't know after how many times will the temperature module give value to the computer. Say you're measuring the temperature of your room. How can you be sure that the temperature module is giving you values after 1 second or 2 second? That depends upon the baud rate. Like the baud rate decides that after how much time is the Arduino taking values from the temperature sensor and providing those values to the computer. Now, whether the computer uses the values after a 100 millisecond delay or a 200 millisecond delay depends upon the code. But after how much time does the Arduino provide the values from the module to the computer is depends upon the baud rate. So when you're using modules, then it will come in more relative terms. Right now, it is not much of relevance.
Okay.
Yeah, so like I said, the serial monitor is just for debugging your particular code when you are going to work on on some complex on some complex circuit. So you can see it, you can feel its benefit then. So right now it wouldn't seem much. Someone just asked in the chat like what to do after this code. Like you need to just start the stimulation here, click on it, and it will initialize for some seconds or a few seconds, and the LED will start glowing. Like someone also asked that what is delay doing here? Why is the delay 2000 instead of 1000? The delay, the milliseconds in this delay is your wish. You can delay till like you can delay it for 10 seconds, you can delay it for 1 hour, doesn't matter. As long as the Arduino board is getting the power, it would follow this logic, the commands which you tell it to. Yeah, so that's it. I think that would be it. And now you would, and now Priyanshu Shubham would explain to you one more circuit about blinking, one more circuit about fade in, the one more. Yeah. So Priyanshu Shubham.
Shubham, you can share your
Hello
screen.
guys. Hello guys. Am I audible?
Yeah.
Okay, so someone asked in the chat window that what about the brightness of the LED? So in this example, we will be dealing with the brightness. Okay. So here, can you see my screen? Hello.
Yes.
Okay, so let's create a new circuit, and what we want to do is we have a LED bulb. We first want to fade the LED bulb from off to on, and then fade it back from on to off. Okay, do you get it? Hello. Like, please
Yes.
reply. So first thing
Yeah,
first,
yes,
of
we
course,
have
we
got
need
you.
a of course we need an Arduino board. So here it is. Now LED also, like, we need that. Here it is. Now, as Abhishek told that we don't need a resistor. It's just a like we don't need it when connecting it to an Arduino. So now I have a question for you guys. Like, we need to change the value for the LED's output. Okay. So what do you think? Which pin should I connect it to? 12 or 11?
11.
Why
11.
so?
11, I think.
11.
Why
It's
so?
analog.
11,
It's analog. It can take multiple values.
Yeah,
it can take,
okay.
yeah.
So let me just connect it first. And this is connected to this. Okay. So now coming to the code part. Uh, let's change it to the text one. Continue. Yeah. So now, what should be the pin mode of 11B? Output, right? Yeah, guys.
Yes.
Yes.
Okay. So now in the loop part, we need to first increase the brightness from 0 to 255, then like from 0 to full brightness, then change it back from full brightness to 0, right? In each loop, we want to do this. So first thing first, do you guys know about what variables are?
Yes.
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 Okay, so let me declare a variable v whose initial value is 0. Okay, so now in the loop part, first let me write the code, then I'll explain it. Why?
So can someone of you tell me that are you known with for loop and the while loop, or you are doing any of one of those?
Yeah, we know.
We know.
Yes, we
Yes,
know.
we know.
We know.
Yes.
Okay, great.
Okay, so now, first thing first, we declare a variable v equals 0, like a variable v whose initial value is 0. Here, we will indicate the voltage that we are giving to the 11th pin. Okay, so like here, first, we need to increase the value of V from 0 to the full max value that we can have. In an Arduino board, the max value that we can give is 255. So while V is less than 255, we are increasing the value of V by 2 units each time. And now, most important thing I forgot to. Yeah. So when we increase the value of V from first it was 0. When first time this loop runs, the value of V becomes 2, and then we write the value 2 to the this pin. That means 2 upon 255 into 5 volts. That is being given to this pin right then. Okay. So the next time this loop runs, like here we are, so it will be again increased by 2 units. That means the V will increase to 4 units. Again, 4 units will be returned to this pin, and so on. The value will of V will keep on increasing until V reaches a maximum value of 255. And when it reaches the value of 255, this loop will break and will come back to this loop. In this loop, we are decreasing the value of V by 2 units each time. This 2 is not means I've just taken this number so as to demonstrate here. You can choose any number. That should be an integer between like whatever you want to decrease or increase to. So by each time this loop runs, the value of V is being decreased by 2 units until V is greater than equals to 0. So when when this main loop runs, the value of V is equals to 0, and then it increases from 0 to 255, and then it decreases to 0. Then again this loop runs, value of V is 0, it increases to 255, decreases to 0, then again this loop runs. You get it, right?
Please, will you explain it again?
Which part?
From first loop.
Okay, so when
थोड़ा मतलब
this,
सिलेक्ट कर करके बता जरा ना, सिलेक्ट कर दे
okay,
वो
yeah.
पार्ट.
First, in the main loop, we are like declaring a variable v that whose initial value is 0. Okay, and then we are making a loop that will increase the value of v by 2 each time this loop runs. So first time this loop runs, the value of v will be 2, and then we will write a value of 2 to this pin 11 that is given here. Analog write 11, pin number 11, the value v. Value of v will be 4, will be 2 the first time this loop runs. Then again this loop runs, the value of v will be increased to 4 because an increase of 2 units, and then we will analog write 4 in this pin until until the value of v is less than 255. This loop will keep on iterating. Okay, when value of v is v reaches 255 or greater, the this while loop will break and we will come to this while loop. Here, when till when this value of v is greater than equal to 0, this while loop will run. That means we will, and in this while loop, what we are doing is we are decreasing the value of v by 2 units each time, and then we are analog writing that value to this, the same thing. So until and unless the value of v is greater than equal to 0, this loop will keep on iterating. That is, first the value of v is equals to 0, then it increases to 255 until 255, and here we are in each iteration we are decreasing the value of v by 2 units, so then it keeps on decreasing until it reaches a minimum value of 0. Okay.
Yeah, sorry to interrupt you, Priyanshu. Some of them are actually asking for you to repeat the meaning of analog, right? They're not clear with it.
Yeah, also just copy paste the code into the
And
chat, Priyanshu.
Hello, Priyanshu, are you with us?
हेलो, क्या कुछ एरर आ गया? प्रियांशु
hello,
आवाज आ रही? हेलो प्रियांशु.
hello, आवाज आ
हाँ
रही है
हाँ, आ
मेरी?
रही आ रही है. थोड़ी देर के लिए चली गई थी.
Okay, sorry. So क्या क्या बोल रहे थे? Let me
Yeah, so
see.
actually some of them are asking for you to explain the meaning of analog, right? That we are
Yeah,
using.
okay.
And also
So
share the code.
okay, yeah, sure. So, and like for each pin that we have here, for example, that first
Yeah, Priyanshu, I guess your voice is breaking. Anyhow, never mind. I can take on it. So, can you guys listen me? Hello, am I
Yes,
audible?
Hmm.
भैया.
Yes,
Yes,
yes.
sir.
Okay, so
Yes,
Yes.
yes, your voice is coming.
yeah. So we are considering analog write, right? For analog write, we have just basically explained you two type of writes. So one is the digital write and one is the analog write. So in digital write, there is only two kind of values that can be provided. It's a 0 or 1. So basically, you can say it to be in terms of analog, it is like 0 and 255. So there are two big steps that you can take, and you cannot take any step that is in between them. You cannot provide the voltage of say 2 volt at the pin number like 13. You can provide only a 5 volt or a 0 volt. So that is what we wanted to change when we are using a pin number 11. So pin number 11 is actually able to divide the range that is 0 to 5 volt into 256 steps. So these 256 steps will actually help us to change the brightness of the LED. So in LED, what is happening is the voltage that is being provided to it is proportional to the brightness of the LED. So in 256 steps, what we are doing is we are uh, in after like a delay of 5 microseconds, we are increasing the voltage that is being delivered to the LED by two segments. So it will be like 5 upon 255 into 2. By that voltage, it will be increasing again and again till it goes to a maximum of 255. So this value, when it will reach a value of 255, it will keep on decreasing. So for that thing to happen, we have to have a different kind of function. We cannot use a digital write, because the digital write does not know that how it can give a value of a middle value in between. So we are using analog write for that purpose. Does that solve your question?
Yeah, thank you.
Mhm. Prenshu, have you shared the code on the chat?
Yes, I've done that. Let me do that again.
Okay, so now let's move on to the problem statement. So guys, I think Prenshu, you can explain
Yeah.
the
Are these
problem
codes
statement.
case sensitive?
Yes,
Hello?
yes, they are case sensitive. Yes.
Hello? Okay, okay.
अभिषेक मेरी आवाज आ रही है?
आ रही है आपकी आवाज?
Okay, so before giving the problem statement, if anyone has any doubts regarding the session, whatever they have all have covered, you can ask it. Any slight doubt or anything which you want to ask. Anyone? Turn your mic on and speak if you want. Okay, I guess no one wants to ask. So, like before telling the problem statement, like I would tell, like you just don't have to do it first. Like it should be, we have to do it correct also. The one who will be doing it first and correctly will be getting something from the Robotronics Club when you reach back campus. Okay, so the and yes, one more thing, like the problem statement which I'll be telling you, code should be equal to the problem statement and not the way you think about it. Like understand whatever I speak, and if you have any problem, then please ask it again. I'll explain it again. Okay. So like you all will be using two LEDs. Like Tanmay, are you showing the simulation?
Yeah, so it's with Priyanshu Shubham, not with me.
Pranshu, Pranshu is showing.
शुभम शुभम फिर से बना दे मतलब एक बार.
Yeah, I'm showing it.
अच्छा ठीक है. Okay. So like you will be using two LEDs and like something which you see during Diwali, something similar to that you will be making. So one LED would be fading in and the other one would be fading out. By fading in, I mean like from from dim, it would be going slowly. It would be getting to its highest light, and the other one would be dimming at the same time. Not it's not like that. First one will go to its highest value, and then the other one would go to its lowest value. It should be like one is fading in, like it's going up, and the other one is getting dimmer and dimmer. It is fading out without any time gap in between. It should be going on simultaneously.
Bhaiya, could you repeat again?
Okay, so you will be using two LEDs as Shubham is presenting on the screen, similar to that, and you have to write the code for that. Like one LED should be fading in, and the other one should be fading out. Is that clear? The meaning of fading in and fading out is clear to everyone? Okay, I think you are clear with it. Yes.
इसको zoom in नहीं कर सकते इसको जरा अगर clear नहीं है.
Okay, so both should be fading in and fading out at the same time. And second thing you have to take care of is that there should be no time gap in between.
Now you have already seen the circuit, so the only coding part remains. So the one who does it the first time and the correctly will get the prize.
And you just write your name or like tell us in the chat box that you have completed it and your code is working fine and it's according to the problem statement which I have told you. It's clear, everyone?
Yeah, so you guys can now start working on it.
You can open your Tinkercad and start working on it. I think
it should not take more than 10 minutes, I suppose.
Yeah, it should not take more than 10 minutes. Yeah.
Also, once you finish, comment your name in the chat or just you can raise your hand too, so that we can know you finished.
Okay, so we have a response that one of the person is done. So can you like share a screen and show us?
Yeah.
Aniket. No, you can simply share the screen.
You can present your screen directly.
The code seems to be correct, I think.
Yeah, the code is correct. It is fine.
If the simulation is correct, then we have a winner.
Yeah.
The task was simple. No problem.
So, Aniket.
Okay. So yeah, so guys, thank you for the.
Traffic lights example too.
I think we are running out of time, right? Or are you guys still enthusiastic?
Other guys keep on doing it. I think there's some mistake in the code. Maybe Prashant is saying that there is some mistake in the code.
Okay, so we have a winner, guys, and overall, I would like to thank the team for conducting this session in the like online mode. Usually, this is like on a hands-on session. You have Arduino in your very own hands, and you like do it physically on your own laptop, and it's really interesting.
1 minute, Abhishek, 1 minute. Prashant, code सही है ना उसका?
Yeah, the code is.
इन मोड नहीं अमित का गलत है ना
विनायक का
अमित
कोड
का
सही है, विनायक का
अमित
कोड
का
सही है,
गलत है
अमित का गलत है।
अच्छा, okay. My mistake.
So yeah, I would like to thank again my like our team for like conducting this session, and thank you all guys for attending this session. We are going to have another session. We'll be uploading the date, like timing and the dates on the Discord and other
गाइस बता
platforms,
दो कि सेशन कैसा लगा
which would be on which is on modules. So like if you have any feedback and all, we are open right now. General discussion.
Yeah, so
Hello.
we will be discussing the solution right now. So it is not like one of them has solved that, so the thing is now blown up.
Okay,
You can
guys.
still try on.
और भी problem statements
Try
होंगे और
that.
प्राइज होंगे, ऐसा नहीं है. Every session will have a different core team and a different what do you call that, prizes. So stay tuned.
Yeah, so all of you have like given your try, so we can discuss the solution if everybody has given a try. You can stop pasting up your solutions in the chat box. I guess we have a winner now. So you can try on your own. If you think that your code is fine, then we can discuss the solution now. Is there anyone who is still doing it? We can wait for a couple of more minutes here.
I think we should discuss the solution now.
Yeah. So we can start now.
Priyanshu, you can share your screen.
Shubham, na?
Yeah.
Just a second. Abhishek, are you taking up the explanation?
Nani, you can explain.
Okay, so in this one, like it is very similar to the previous question.
Pranshu, share the code in the chat box.
Okay, yeah, sure. Yeah, it is very similar to the previous question that we did. The only difference lies between that here we have two bulbs and we have to alternate the fading in and fading out effect in these two bulbs. So like in the previous question, we had a variable that will store the voltage that we give to the bulb. Here we have two variables that will store the voltage that we gave to both the bulbs, like V for this one, yellow bulb, and V2 for the green one. Now, what we do is while V is less than 255, the rest of the logic stays the same. V keeps on, V increases and then decreases, and V2 increases and then decreases. So rest of the logic stays the same. You can see the code here, and if you have any doubts, you can ask.
Like basically, like in the previous case, you had a variable v, right, which was causing the increase in the brightness. Now here you have another variable v2, which is causing the decrease in brightness. I think that sums up the explanation.
Yeah, so who was actually the first one to complete it? Can you just remind me once?
I think it was Vinayak.
Vinayak.
Nini,
Aniket,
was
I think
Aniket's
was listed first.
Sukhija, Aniket Sukhija.
Aniket Sukhija. Yeah, so
Yeah.
congrats Aniket for doing it correctly. And for the other ones, like we are still here. Some of us will be still here. If you want to ask any doubts, you can ask. Others may leave if they are like now bored. We know that we have been taking very long.
One and a half hour session.
Yeah, yeah.
Could you please explain the problem? What was to be done?
Yeah, the problem was like that we are having two light bulbs, LEDs, sorry. So LED 1, as it is glowing up, the LED 2, it is fading out. And similarly, when LED 2 will be glowing up, the LED 1 will be fading down. So it is like, they are complementary to each other. So if you can see that there is a voltage that is being provided to them. So, so like here we have made use of 0 to 55 values. So the sum of their the analog rights that will be provided to them, it will be 255 always. We are making that and the use of that property. Are you still having
Okay,
any
yes, got
got it? Okay. Yeah, we can wait till
I think there
8:25
are
and
some doubts in
then
the
we
chat
can
box.
leave. We all can leave.
Oh, I
So,
think there are some doubts in the chat box.
yeah.
भैया एक डाउट था
Yeah.
अपन ने जो सबसे पहला वाला सर्किट बनाया था जिसमें अपन डिजिटल सिग्नल की जगह किया था वो डिजिटल जिसमें एक रजिस्टर एक एलईडी थी तो उसको जब अपन सिमुलेट करते हैं तो अपने जो बोर्ड पे एल वाला जो साइन है उसके आगे भी एक डॉट वो ब्लिंक करता है।
Yeah.
पर अभी अपन जब एनालॉग सिग्नल दे रहे हैं तो वो ब्लिंक नहीं कर रहा, तो उसका कोई रीजन है क्या?
So
Okay, so
हाँ
L is depending on the digital, right?
नहीं नहीं, तन्मय एक्सप्लेन कर सकता है, तन्मय।
Yeah, Tanmay, you can go.
So Rishabh, yes, I think that was you were asking about, right? So the LED, the L pin is connected directly to pin number 13. So
हाँ
whenever we are using that pin, so I was using digital light for that particular example. So hence it was high and low once and everywhere. English सही है ना? हिंदी में बोल दो।
हिंदी में बोल लो, हिंदी में बोल लो।
ठीक, तो जो एल वाला छोटा सा एलईडी है वो डायरेक्टली पिन नंबर 13 एंड पिन नंबर ग्राउंड पिन को कनेक्ट
ग्राउंड,
हुआ है। सो
ओके।
इसीलिए तब मैंने उस एग्जांपल में पिन नंबर 13 यूज कर रहा था, इसीलिए वो ऑन ऑफ हो रहा था। अब इसमें जो एग्जांपल अब जो स्क्रीन पर प्रेजेंट कर रहा है उसमें पिन
हाँ
नंबर 13 यूज नहीं किया है, इसलिए वो ऑन ऑफ नहीं हो रहा है। अगर यूज करोगे तो शायद वो फेड इन फेड आउट हो गया। एक बार ट्राई कर लो तुम भी, मतलब
मतलब
पिन
बेसिकली
नंबर 13।
आर्डिनो
मतलब
खुद भी
उसका,
एक एलईडी प्रोवाइड करता है ना, चेक
हाँ
करने के
हाँ
लिए, ताकि हम
वो
बार बार
जैसे
एक्सएलईडी यूज ना
मतलब
करें।
वो मतलब डीबगिंग के लिए है कि डीबगिंग है ना, ये देखने के लिए है कि पिन नंबर 13 में तुम्हारा वोल्टेज जा रहा है या नहीं जा रहा है। अब एक सिचुएशन में देखो कि तुमने पिन नंबर 13 दे रखा है कोड में और एलईडी नहीं चल रहा है, और बोर्ड पर जो छोटा सा एलईडी है वो भी नहीं चल रहा है, तो तुम तब बोल सकते हो कि पिन नंबर 13 में वोल्टेज नहीं जा रहा
तो
तुम्हारा
अपने
एलईडी ठीक
वेरीफाई
है।
करने के लिए।
हाँ,
प्रॉब्लम फाइंड आउट करने में यूजफुल होता है वो।
मतलब इसका अपने एनालॉग और डिजिटल सिग्नल से कोई मतलब नहीं है। जैसे अगर अपना 13 अगर अपन अज्यूम करके वो भी टिल्डा होता, उसमें अपन एनालॉग की जगह देते तो होता कुछ चेंज?
नहीं नहीं,
हाँ, हो
वो
सकता है, होगा
13 का
वैसे।
मतलब वोल्टेज भी
वैसे
देगा।
react करता।
अच्छा
हाँ,
अच्छा।
थैंक यू भैया।
पिन नंबर 13 एनालॉग नहीं है ना, इसीलिए।
हाँ, तो अभी react नहीं
हाँ
करेगा वो।
ओके सो
Okay, तो मैं recording
सो ऐसे ही।
भैया
हाँ हाँ बोलो।